So in this lesson, we're going to discuss how do we graph a linear function and then how do we determine what its attributes are. So first of all, here we have a line. So obviously it has an x here and this would be my y. The y-intercept is 2, the slope is 2. So the very first thing that we want to do is we need to graph a point that we know. Well, we know that we have a point at the y-intercept of 2. And then after that, what we want to do is we want to graph other points by using the slope. The slope here is 2, so that means I'm going up 2 over 1 here. So let's get additional points by going up 2 over 1, up 2 over 1, up 2 over 1, and then I like to get some points that go backwards by going down 2, but to the left 1. So we're going backwards 1. So down 2 over 1. Down 2 over 1. And then once we have that, we take our ruler and just go ahead and make a line here as best as we can that go through these points. Because there are definitely more points, so we're drawing the line because we could have had points that are decimals in between. And we also have to draw arrows because there's more points, but I'm not going to sit here and graph them all. So we're just going to do arrows to kind of acknowledge that we have that. So now let's go ahead and identify its attributes. The first thing we want to identify is its domain. Well, there's an arrow to the left and an arrow to the right. So obviously my domain is all real numbers. My range here, I have an arrow going down, an arrow going up, so it's the same thing. It's also all real numbers. Let's write that just a little bit better. So all real numbers. Now my 0, remember that a 0 is just the x-intercept. It's this point right here. So it is the point 1, 0. My y-intercept is where the line hits the y-axis. So it's this point right here, which we knew from the beginning. It was 0, 2. We knew that from the equation. Our slope, we knew that as well from the equation, but let's just make sure that we did the correct slope. Up 2 over 1. Like, look at that on the graph, it's there. So my slope is 2. The type of slope here is positive, so I'm going to just put a plus. Now we need to identify what f of 3 is. So what is the value of y when x is 3? Well, we're going to look here. When is x 3? 1, 2, 3. Let's go up here to get a point. Okay, it's this point right here. Well, what is the y value? 1, 2, 3, 4, 5, 6, 7, 8. Another way you could have identified that is by plugging in 3 here to my equation. So if I did f of 3 equals 2 times 3 plus 2, well, what's 2 times 3? It's 6 plus 2 is 8. So that's just another way to kind of check what f of 3 is. You can look at the line or you can come here and plug it back in. So what is the value of x where f of x equals 8? Well, we just figured that out. It's 3. And again, you could have set this equal to 8 and solved backwards. So let's see. So 2x plus 2 equals 8. If we solved for x, we would subtract 2 and we would have 2x equals 6. Divide by 2 and x equals 3. So it works. Okay. Now in this case, we have our linear function is written in a different way. It's not written in slope-intercept form. This is actually called point slope, and we will understand it a little bit better in the future. But for right now, what we're going to do is we're going to change this to slope-intercept in order to be able to graph it. So the first thing that we're going to do is we're going to distribute this negative 1/2. And so we have negative 1/2 x. And then negative 1/2 times negative 4 is going to be a positive 2. Then we're going to add 3 to our both sides. So we're going to combine it here with the 2. And we have that our line is negative 1/2 x plus 5. So great. So first we need to, just like before, we need to graph our y-intercept. So this is a point on the graph, so that's why I'm going to graph it first. 1, 2, 3, 4, 5. This is my y-intercept. The slope is not a point, but the slope can help us get another point because I know how far they need to be spread apart from each other. So I can start with this point and we can go down 1 over 2 because that's what the slope says to do. And we can keep going down 1 over 2, down 1 over 2, down 1 over 2, and down 1 over 2. Usually if I have my x-intercept and I have my x-intercept and my y-intercept, I think I'm good. I don't need any more points as long as I can identify what those are. And then we make our line that goes through this the best way that we can. And then of course we need to make sure that we are including an arrow on here because we can keep going this way and we can keep going that way. So our domain again is all real numbers because you can keep going to the left and you can keep going to the right. So all reals. My range is the same thing as all real numbers. I can keep going down and keep going up. My 0 here is right here. And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means the x value is 10, the y value is 0. My y-intercept is 1, 2, 3, 4, 5, so 0, 5, which we knew from the equation. The slope is, it goes down 1. Let's go ahead and show that here on the picture. So down 1 over 2. So it goes, it's negative 1/2. This is a negative slope because the line is going down. So what is f of 2? So first of all, we can look here on the graph and look at, well, when x is 2, what is y? I have this point right here. 1, 2, 3, 4. So 4. Or we can plug in 2 in here. Let's check. Negative 1/2 times 2 plus 5. Well, negative 1/2 times 2 is negative 1 plus 5 is 4. So good. And then what is the value of x, where f of x equals 4? Well, we just figured that out. It's 2. Okay, so now in this case, again, it's not written in slope-intercept form, so I'm going to have to change it. So we're solving here for y. The first thing, remember, the first thing that we need to do is subtract 5x from both sides. And so we have 2y is equal to 10 minus 5x. And then we have to divide both sides by 2. So I have that y is equal to 5 minus 5 over 2x. Our equation is not really written in proper slope-intercept form because my slope is at the end and my y-intercept is coming first. So let's switch those. So we have y is equal to negative 5 over 2x plus 5. So my y-intercept here is 5, and that is a point that I know, so we're going to graph that first. 1, 2, 3, 4, 5. And then we're going to get more points by using our slope. So our slope goes down 5 over 2. And at this point, we have the y-intercept and we have the x-intercept, so we really don't need to graph any more points. So let's go ahead and make a line through this. As best as we can. Okay, there we go. And make sure that we can put arrows on these so that we know that it's going, it keeps going. So again, our domain keeps going, so it's all reals. Our range is the same thing. Our zeros here, our 0 right here is this point right here, which is 2, 0. Our y-intercept is up here, which was the point 0, 5. Our slope, it goes down 5 over 2, so negative 5 over 2. It has a negative slope. F of 0, well, what is the value of the function when x is 0? It's right here. It's 5. I can always plug in a 0 in here to check. Well, let's see. If I plug in a 0 here for x, what do we get out for y? Well, these cancel, and we're left with y equals 5. So good. What is the value of x where f of x equals 0? So when do we get out a 0 for our y? Well, right here at x equals 2. Again, we can we can just go ahead and set this equal to 0 and solve it that way. And we would also get 2 in this case if we went ahead and did that. Or we can plug it in here, which doesn't have a fraction, which is easier, and that would work as well. So now let's do this last example. So here we have f of x equals -2. Notice we don't have an x here in this function. This is just saying that y equals -2. So think about it. If I plug in a 1, I'm going to get that y equals -2, which is down here. If I plug in, so 0 is -2. If I plug in a 1, I get out a -2. If I plug in a 2, I get out a -2. And so forth. Your y's are always going to equal -2. So this line basically looks like this. Y is always equal to -2. And one of the ways that I kind of like to remember is if it's a y equals, then it cuts through the y's. Y is always -2. Also, another thing you can do is just make a table, right? I know that y is always equal to -2, no matter what. And then this is going to be whatever I want it to be. And so when I plug in that, this is the line that I get if I went ahead and checked all those points. So here my domain goes from left to right, so it's all rails. Now my range is not. My range here is discrete. It is one number, just -2. There is no 0 here because I never hit the y-axis, so NA. The y-intercept here is obviously -2. The slope, so let's think about Mr. Slope Guy. This would be his mouth, so this is a slope of 0. Again, the type of slope is 0. When I plug in a 0, what do I get out? I get out a -2. What value of x do I get out a -2? Well, all row numbers. It doesn't matter what you plug in, you're always going to get out a -2. All right, so I hope that you found this video on graphing lines useful and that you've taken good notes.